All right, everybody. Good afternoon, good evening. Welcome to another live stream. My name is Dr. Drew, PhD in chemical engineering. Today we got several general chemistry practice problems that I'd like to go over. And tomorrow I'm doing a free review session where we're going to go over as many of these as we can live on Zoom. And today I'm going to basically just do some live preparation for that live stream. If you want to sign up, it's not too late to join. And shoot me a DM for the link to sign up. But we're going to go ahead and effectively do the practice problems. So if you want to rewatch the video that will come out tomorrow, these are the practice problems that I'm going over on that live stream, slowly, bit by bit. And so here we have the first one here. How many valence electrons does each of the following species contain? So we have N2, HCl, NH4+, and Cn-. Okay. So let's start off with N2. How many valence electrons does each species contain? So if I have N2, I need to be really confident with knowing how many valence electrons each of my elements has. So nitrogen by itself has 5, but I have 2 of those, so 5 times 2 is equal to 10. So the number of valence electrons for the species N2 should be approximately equal to 10. Okay, next up I have HCl. Jasmine, welcome in. So HCl is going to have one H and one Cl group. So I need to be, again, comfortable, and I need to know that H has 1 valence electron. Cl is going to have 7 valence electrons. So in total, we have a total of 8 valence electrons. Sabrina, welcome in. Yag, welcome in. Welcome in. Yeah, Whip, welcome in. Thank you for the love, Jasmine. Okay, so the second answer, the first one was 10. Second one is going to be approximately 8. Sabrina, thank you for the love. Samrit, Faith, welcome into the chat. We're going over some general chemistry practice problems today. I know some of you guys are taking OChem. Guys, today we're going to focus on Gen Chem. How's everyone doing? It's G, welcome in, and welcome into the chat. Next up, we're going to have C, NH4+. NH4+, that's going to be ammonium here. All right, so typically nitrogen is going to have how many valence electrons? 5 plus 4 times 1 is going to be 1. But now I'm adding a positive charge. So I have a positive charge. So if I'm giving a positive charge, that means I'm taking away 1 electron. So I have to subtract 1. Okay, so this 5 is because I have nitrogen has 5 valence electrons. And then 4 of these H's. Yo, I don't know if you remember, but I had to take Chem 1 last semester for the very first time. Yeah, I remember. I remember you, bro. Did you come through the live stream, right? -1 because I'm adding a positive charge. That's the tricky thing about cations. Anions means I'm giving an extra electron. Cation means I'm taking away 1 extra electron. So 5 plus 4 is 9, -1 is 8. Okay, we have a complete octet. 97% W. Good job. All right, last one is going to be Cn-. So how many valence electrons does Cn- going to have? So same idea here. So Cn is going to be 4. Carbon has 4. Plus nitrogen has a total of 5 valence electrons. But I have a minus charge. So am I going to give 1 electron or take away 1 electron? Thank you, it's G. I hope those are helpful. Nice. If you're on Gen Chem 2, that's going to be good for you. What's your major, by the way? So I'm going to give 1 electron because I have to give 1 extra electron. Good job, Jamie, right? Hi, Jamie. Good to see you. So that's 4 plus 1 is 5 plus 5 is 10. Hey, everyone. I'm doing a free live review tomorrow at 6 o'clock PST. So if you want to join, just DM the link. Lisa, welcome in. Addie, welcome in. Ju, thank you for the follow. Ju, are you currently a STEM major? What are you taking right now? Okay, so this is our very first problem, everyone. We got 10 valence electrons, 8, 8, and 10 for N2, HCl, NH4 plus, and Cn minus. And cool, everyone. So cool. Going over these practice problems, let's pull up the next one. Psychology major, have to take those classes because I've got to get into med school. Nursing school, shouts out all the nurses, psychology, nursing, pre-med. Okay, so the next one we're going to do is drawing the Lewis structures for each of these. So we're going to draw the Lewis structures for CCl4, okay, CCl4BH3, SiF4BH4 minus PH4 plus. So I'm going to go with carbon Cl4 first, and that's going to be my first compound. Okay, so a lot of the times drawing Lewis structures is going to take practice. Okay, drawing Lewis structures is going to take practice. So I'm going to start off with CCl4, and step one going to be to identify the center atom. Some of you asked me, thank you for the heart me, Jamie. How do you know what's the center atom? I don't know. I'm going to guess. So I'm going to guess that carbon is my center atom. How do I know? I don't know. I'm going to guess. I mean, hopefully it makes sense because carbon has 4 valence electrons. And then I have 4 bonds to Cl. So I'm going to draw carbon and then 4 bonds to Cl. Just like that. 1, 2, 3, 4. You might say, hey, Drew, you skipped a bunch of steps. What happens to your valence electrons? I know, I skipped a bunch of steps because I want to go quickly today and do the bonds to atoms, not the valence electrons. Yesterday we went over the valence electrons. I already posted that video on my channel. Today we're going over the bonds of atoms. It's going to take practice. You're not going to see it right away. So I already know right off the top of my head, this is going to be a tetrahedral CCl4. Okay? I'm liking STEM. I thought I was going to hate it. I'm glad you're liking STEM. Isn't it low-key fun? Nisi, thank you for the follow. Are you a STEM major? What are you taking? Are you taking Gen Chem right now? Nisi, thank you for the follow. Thank you for the love. Ju, thank you for the rose. And cool. So let me know if that's making sense, guys. So drop a thumbs up if you're understanding CCl4 right now. CCl4 is a tetrahedral compound. Let's try the next one, BH3. Now, same exact thing here. I'm going to guess the center atom. BH3 is one that I want you to memorize, chat. BH3, you have to memorize because why? It's an exception. It's going to have an incomplete octet. It's going to have an incomplete octet. So I need to memorize and be confident, and I know that B is my center atom. How do I know it's my center atom? I'm going to guess. So I have a B and 3 H's on the side. This is going to be called trigonal planar. If you're going over your molecular geometry class chapter, this is called trigonal planar. How do I know that it looked like that right away? Because I know I have B has an incomplete octet. This is incomplete. You have to basically just memorize that. So typically they like to have how many electrons, chat. Chat, comment down below how many electrons each atom typically has. Jude, thank you for the thumbs up. Isaac, good to see you. Thank you for the follow. It's a toxic relationship because I get stuck and frustrated, but I want to understand what's going on. No, I felt that. No, I felt that for real. I felt that for real. Try not to, like, how do I say this? Try not to, like, don't overwhelm yourself, okay? Keep being curious, keep asking questions, but like don't overwhelm yourself. Sometimes you gotta say like, hey, I need to figure out why. Ask yourself why. Why is this happening? Why is this true? But sometimes you gotta learn how to just let it go. Sometimes you gotta just let it go. Hi Kiki, how's it going? Ju says A, good job, Ju. Thank you, Jamie. Appreciate the shout out. Okay. So guys, next one I'm going to do is SiF4. No, someone said trigonal pyramidal. No, this is not trigonal pyramidal. This is trigonal planar. Okay, next one I'm going to do is SiF4. Appreciate you, Jimmy. Okay, so this is Si. Okay, so how many valence electrons does Si typically have? Si lives right under carbon. Okay, let me pull up a periodic table. Si lives right where? Right under carbon. Jamie, I forgot to text you, but I'm having a review session. I'm going to send you the link. It's going to happen tomorrow. Can you make it? Jamie, I'm going to text you. Okay, Si lives right under carbon. So that means carbon is going to be isoelectronic to Si. Carbon is going to be isoelectronic. So I'm going to have 1, 2, 3, 4. How do I know it's 4? Because it lives in this column here. It's gonna be at 6 o'clock PST. Ooh, that's gonna be late for you, huh? That's gonna be a little bit late for you. It's 6 o'clock PST. Okay, and then if I have SiF4, then I'm gonna bond my F atoms right next to that. Okay, guys, I am recording this live on YouTube, so you can rewatch the playback or just sign up for the live stream tomorrow. If you can't make it, I'm gonna record the whole thing. So this is my next Lewis structure for SiF4. Yes, Olivia, going over Lewis structures. I'm just going over some practice problems for my review session tomorrow. If you want to join, shoot me a DM. Okay, let me know if there's any questions for SiF4. Guys, do me a favor and drop a thumbs up if you're liking the live so far. Okay, if you're liking this and this is helpful, drop a thumbs up down below. Next one I'm going to do is BH4 minus. So BH4 minus. Again, sometimes you ask me, how do you know? I don't know. I'm going to guess that my center atom is going to be boron. How do you know? I don't know. I'm going to guess. And boron, last time we said it was only going to have 3. But this time it's going to have another, is going to have a complete octet here. So I'm going to assume that B is in the center here. And we have our H's on the side just like that. Okay, and we're going to have a minus charge, and I have to have brackets to indicate that the overall charge is minus. Some of you forget the brackets, and your professors are really tough. They're going to take away points if you forget the brackets and the overall minus charge. Okay, they're not doing it because they hate you. They're doing it because if you don't, okay, this is wrong. If I do BH4, this is wrong. This is wrong, okay? This has no charge. BH4 has a charge. Madeline, thank you for sharing. Maria, thank you for the thumbs up. Okay, Xavier, thank you for the follow. Xavier, what's your major, brother? Are you chem major, STEM major, or non-STEM? You're just hanging out here for the vibes. Okay? Good. Tetrahedral, good job, Sam. This is called tetrahedral. Chem professors are stricter people I've encountered so far. No, for real. Chem professors are so strict. Like, at least math professors, like, they can, like, explain stuff and, like, you know, they're hard. Like, math is hard, but it's not strict. Chem, it's not even that hard. It's just, like, so strict. If you forget one small thing, you're done. Okay, next one is pH4+. pH4+, guys. So how do I know what's the center atom? Lo, thank you for the follow. The bond angle for tetrahedral is 109.5. Please memorize that, everyone. The bond angle for tetrahedral is 109.5, excuse me. So next one is pH4+. So what's the center atom? What's the center atom? So center atom, I don't know. I'm going to guess. It's probably going to be P, right? Because P is going to be in the center here. Okay? And I'm going to have 4 bonds to H here. Guys, I'm just going over some practice problems for Gen Chem. Okay? And here we have 4 different bonds. Here is going to be 1, 2, 3, 4. And, well, phosphorus typically has a stable octet, but phosphorus typically likes to have... Okay, we got to do the charges. So if I have 1, 2, 3, 4, 5, 6, 7, 8. Do we know about formal charge? Chat, how do we do formal charge? Chat, I don't think your professor is going to give you this equation. This is my famous formal charge equation. What's formal charge? Formal charge is going to be equal to the valence electrons minus the dots plus lines. I don't know why I haven't seen anyone talk about this equation. This equation is so helpful. So what is formal charge? It's the number of valence electrons minus dots plus lines. So phosphorus typically has how many valence electrons? I don't know. I'm going to check. How do I check? I'm going to check the periodic table. So if I forget, I know that phosphorus lives right next to nitrogen. Okay, so nitrogen typically has 5, so that means phosphorus has 5. Okay, so, okay, saving you for your midterm on Thursday, I got you. That's why I'm doing the review session tomorrow. Okay, so typically phosphorus has 5. So I'm going to put a 5 minus dots plus lines. What do I mean by dots? I mean lone electrons, not electron pairs, dots. Okay, lone electrons. I don't see any lone electrons, so I'm going to say 0. How many lines? I see 1, 2, 3, 4. So 5 minus 4 is plus 1. So overall is going to be a plus 1 charge. Okay, so some of y'all don't understand formal charge. It's simply valence electrons minus dots plus lines. How many dots? 0. How many lines? 4. 5 minus 4 equals plus 1. Drop a thumbs up if that made sense, and drop a crying emoji if I went too fast there. Hi, Katie. I'm in high school right now. Do you guys have to memorize the periodic table in college? How do I answer that? Yes and no. You don't have to memorize it, but if you memorize it, it is going to save you a lot of time. Great question, Katie. Saving me for my test. Of course, I got you. Daily dose. Just the trends. Yeah, exactly what Loki said. Just the trends. Andrea said that was too fast, so I'm going to do that one more time. The equation for formal charge is going to be valence electrons, however many valence electrons the center atom has. So how many valence electrons does phosphorus have? IDK, I'm going to check the periodic table. So phosphorus lives right over here. So if you don't know how many valence electrons, check out my YouTube video on valence electrons chat. It's on my YouTube channel. Okay? And then phosphorus has the same number as nitrogen. How many does nitrogen have? 5. Okay? So I'm going to put a 5 right here. I already put it. And then minus dots plus lines. What do I mean by dots? Single electrons. I see 0 dots, and I see 1, 2, 3, 4 lines. So that's why I said 5 minus 4 equals plus 1. So that's why I put a plus 1 charge on that one. Okay, great question. Great question. Guys, I'm going to move on to a different problem. I'm just going through some problems here. My local university, UCR, I know you guys have a test on Thursday. So this is straight up for the UCR fam, whoever has their test on Thursday. So guys, I'm doing a free review tomorrow. If you want to sign up for that, again, it's totally free. Just DM me for the link, okay? And guys, we're just going over some of these Lewis structures. Here we go. Okay, so this is the Lewis structures for the oxyanions ClO2 minus and SO32 minus and HCO3 minus. Okay, so now they're getting a little harder, right? So how do I know what's the center atom? I don't know. I'm going to guess. So I'm going to just put a Cl right over here. And then maybe one option, I want to put an oxygen over here and an oxygen over here. Okay, now I need to do this more algorithmically because these are getting a little bit harder. So first things first, I'm going to calculate the total number of valence electrons. So how many valence electrons do I have? Okay, so valence electrons, chlorine has 7. And then oxygen has 6, and I have 2 of them, plus 1 valence electron. Okay, so this is chlorine. Chlorine has 7. Okay, this is from ClO2 minus. Don't forget this extra minus charge that I have to give an extra valence electron. So in total, what is 7 plus 2 times 6 plus 1? So that's about 8 plus 2 times 6 is 12. So 12 plus 8 is about 20. Okay, so in total, I'm going to have 20 valence electrons. Okay, so suppose I have 20 valence electrons, and this is going to be one of my exceptions, I believe. This is going to be my chlorite. This is going to be my chlorite ion. Okay, so for my chlorite ion, suppose that I give 1, 2, 3, 4, 5, 6, 7, 8, a complete octet for my Cl here. Okay, I have 8 electrons, 12 remaining. Okay, so I'm going to give 1, 2, 3, 4, 5, 6 to my oxygen, and then 1, 2, 3, 4, 5, 6 to my oxygen. So that should be about 1, 2, 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, I think I should be good here. Now I need to see the charges here. So now I'm going to turn those into lines. And I need to do my formal charges. So again, the formal charge equation is number of valence electrons minus dots plus lines. And I have to do that for every single atom. So I'm going to go quickly. Okay? I'm going to do that quickly here. So oxygen has how many valence electrons? Okay, 6. So oxygen has 6. If you say, how do you know 6? Because of the periodic table. How many dots do I have? 1, 2, 3, 4, 5, 6. Okay, I see 6 minus 6 dots plus how many lines? 1 line. So 6 dots plus 1 line. 6 minus 6 plus 1 is 7. 6 minus 7 equals minus 1. So this oxygen has a formal charge of minus 1. On the right hand side, it's going to be the same thing, but I encourage you to pause it here and do it yourself. It's going to be 6 minus 7. It's going to be minus 1. All right, what about chlorine? So chlorine has 2, 4, 6, 8. Okay, so that octet is complete, but how many valence electrons? Typically it has 7 valence electrons. Minus how many dots? 1, 2, 3, 4 dots. 4 dots plus 2 lines. So 4 plus 2 is 6. 7 minus 6 is plus 1. Okay? So that's bad news because chlorine is electronegative. We don't want chlorine to be electronegative here. Okay, so I'm gonna donate one of this lone pair. Or rather, I'm gonna donate this lone pair and create a double bond. So we're gonna have another exception here. So many exceptions in Gen Chem, guys. I hate that, right? So I'm gonna donate one of this lone pair, create a double bond, and we broke the octet. Why would they make the rule called the octet rule if we're gonna break it so many times? You feel me? So now this is still a minus charge. This is now neutral. 1, 2, 3, 4, 5, 6, 7. Okay. So now overall, this is ClO2 minus. Guys, I know this one is a little bit trickier. Let me know if that made sense. Drop a thumbs up if you're following along so far. Jamie says, intro to chem, it was 1:30. My class right now, chem 1, they want me to remember the non-metal. V, thank you for the follow. Okay, so guys, I'm going to go ahead and move on to the next question here. This is going to be SO32 minus. SO32 minus. SO32 minus. Okay. Thank you, Andreas. So Andreas says thumbs up. So SO32 minus, same idea here, chat. I don't know which one's the center atom. I'm going to guess. So I'm going to guess that sulfur is the center atom. Now this is going to be my sulfite, SO32 minus. That's my sulfite ion. Okay, so if I have sulfite here, I'm going to suppose that my sulfur goes... Okay, I have a couple options here. One of them, I'm going to put my oxygen up on top. And then oxygen on the side here. Okay. One option is I can put oxygen next to oxygen, but that's kind of rare. I don't really want to do that. Okay, I don't really want to do that because oxygen next to oxygen is kind of rare, except for like ozone. So I'm pretty sure I'm going to just have my sulfur next to sulfur. Okay, my oxygen next to sulfur like that. Okay, and then so that's going to be my first guess here. Let me move this down so I can give myself some more room. There we go. And then so that's going to be my SO32 minus. Okay, so now I'm going to have sulfur bonded to oxygen here. So now the problem is I only want 2 minus here. I only want 2 minus. So I'm going to start to add my valence electrons. Let me count my valence electrons. So how many valence electrons do we have? Sulfur is typically going to have 6, and then oxygen is typically going to have 6 as well, plus my 2. So that's going to be SO3 2 minus. So in total, what is 6 plus 3 times 6? In other words, that's 6 times 4 is 24 plus 2. Should be 26 valence electrons. Okay, so now I have SO3. I'm going to have a total of 26, I believe, valence electrons. Now, this is 2 more than 24, and 24 means that I'm going to have a complete octet, 8, 16, 24. So that's telling me that I'm not going to have a complete octet. So I'm going to do a double bond on this oxygen, and I'm going to do single bonds all around. You might say, how did you know that? Because this hint, 26 is 2 more than 24. So 24 means I have a complete octet, which means I'm going to have an extra lone pair on this sulfur. You might say, Drew, how do you know that? I don't know. I'm guessing here, chat. I'm guessing. I'm just trying to figure it out. And then I see if it makes sense. You did the formal charge really quickly. Okay, I'm going to go back. I'm going to show the formal charge. So the formal charge here is going to be oxygen has, remember, what's the formula? It's going to be valence electrons minus dots plus lines. Okay, so how many valence electrons? I have oxygen has 6 minus, how many dots do I have? 1, 2, 3, 4, 5, 6. So 6 minus 6, and I have 1 line. So 6 minus 7 equals minus 1. So this is a minus charge. And if I see single bond oxygen with 3 lone pairs, that means that this is also going to be minus 1. All right, what about sulfur? It's typically going to have 6 as well. So 6 minus 1, 2, 3, 4, 5, 6. So this is going to be neutral. And then this is also going to be neutral here. So I think I'm done here with this one. This is going to be SO4 2 minus. SO4 2 minus. 2 minus. So going over some Lewis structures. Chat, who's still with me? There's only a couple people left. We had a good amount of people. I think people got a little bit discouraged. So who's still with me? Comment down below if this is still helpful. And guys, if you don't understand it, don't worry. I am going to post this up later today. Okay, comment down below if you're still here. Otherwise, I'm going to move on. Thank you, Andrea. Okay, I see you're following along. Is this still helpful? Okay, I'm going to continue because I have to go through all these problems here, okay? Next one is going to be bicarbonate, HCO3 minus, HCO3 minus. Okay, so one tip I have for bicarbonate is that if I know HCO3 minus, this is very similar to my CO3 2 minus here, okay? So this is going to be very, very similar to my CO3 2 minus. So why don't I try to build similar CO3 2 minus, of course, daily dose, similar CO3 2 minus, and then I'm going to simply add a proton, okay? Because if I know carbonate, and I know bicarbonate, and I want to draw bicarbonate, well, why don't I try to draw carbonate first, and then I'll add a proton later. So for carbonate, I'm going to have how many valence electrons? Carbon has 4, oxygen has 6, and I have 3 of these, and then plus 2 extra electrons. So this is my CO3 2 minus. So remember, carbon has 4, oxygen has 3, and then my extra 2 minus, I have to add 2 more electrons. So what is 4 plus 3 times 6 is 18. 18 plus 6. So basically 6 times 2 is 24. So this is telling me I have 24 valence electrons. This is telling me I'm going to have a complete octet. If you don't know your nomenclature, I'm sorry, I wish I had a video on that, but yeah, it's going to take practice. You kind of have to just memorize. Flashcards, queen. Just get your flashcards, okay? So I'm going to have 24 valence electrons. This is telling me I'm not going to have any exceptions here. I'm going to have a complete octet. I'm going to also guess again that carbon is in the center, and I'm going to have oxygen on the sides kind of like this. I'm going to have oxygen on the sides kind of like this. So if I have carbon in the center and oxygen on the sides, I know carbon very rarely makes exceptions. So I need to have neutral carbon. Carbon very rarely makes exceptions. So I'm going to just have carbon with a valence of 4. Okay, and a steric number of 4. What do I mean by, or steric number of 3 rather. What do I mean by steric number? I'm going to just calculate the formal charge. What's the equation for formal charge? Formal charge Fc is equal to the number of valence electrons minus what? Dots plus lines. So what's the number of valence electrons? Chat. How many valence electrons does carbon have? How many valence electrons does carbon have? So if you forget, how do I check? I'm going to check the periodic table. Okay, and I see carbon lives right over here. So this is going to be 8, 7, 6, 5, 4. Okay, if you're not sure what I did here, I put an 8 right here because the octet. And then 7, 6, 5, 4. Okay, you said 6, Andrea. Andrea, you said 6. That's good job, queen, because you have 6 total electrons. I don't want the total electrons. I want the valence electrons. So the valence electrons is the number of electrons in the outer shell. I know you said 6 because carbon is 6. Good job. You said the total number of electrons. No, Andrea, I want the number of valence electrons. So the valence electrons is only on the outer shell. Good job. There you go. Okay, so it's 4. Okay, 4 minus dots plus lines. How many dots do I have? What do I mean by dots? How many lone pairs? How many lone electrons? I don't see any lone electrons here, so I'm going to say 0. I'm going to say 0 plus 4 lines. 1, 2, 3, 4. A double bond counts as 2 lines. Okay, a double bond counts as 2 lines, so that's going to be 4 lines. So 4 minus 4 equals 0. So I'm going to say plus 0 for my carbon. I know that my carbon is safe here. So that's why I started with my carbon, because carbon very rarely likes to make exceptions. Carbon is extra, guys. Carbon is so extra. There's an entire class on just carbon. There's an entire field of chemistry, guys, because carbon is so extra. It's called organic chemistry. Carbon is so extra that there's an entire branch of chemistry called organic chemistry. Okay, so now, now I'm gonna add my valence electrons here. Okay, And I know I have to complete my octet here, so that's how I know I have my remaining valence electrons. Maybe I'm not doing a good job at explaining the oxygen ones. Let me do that again. I'm going to erase that. Maybe that was a little bit too fast. I'm going to erase my oxygens because I know that this oxygen needs to have 2, 4, 8 electrons, right? So I'm going to have 2, 4, 5, 6, 7, 8. So I put 2 over here and 2 over here, and then I have a complete octet from the double bond, okay? And then this oxygen on the side has 1 single bond, and then I got to add 2, 4, 6, 8 valence electrons. Once again, I have a complete octet with 1, 2, 3, 4. Okay, so now this is going to be 2, 4, 6, 8, just like that. If I repeat that process, I'm going to let you do this another time. But if I repeat that process, I'm going to have 6 minus 6 here equals plus 0. I'm going to have 6 minus 7 equals minus 1 here. So I'm going to put a minus charge on this oxygen and then a minus charge here, okay? I know I'm going super duper fast, but I just want to get through as many as I can. Overall, I have plus 0, minus 1, minus 1, overall minus 2. Now, the question wasn't drawing carbonate. This one was carbonate, okay? The question was drawing bicarbonate. Do I go live every day? I go live Monday through Thursday, almost every day, kind of like Monday through Thursday during the weekdays, okay? And then I drew carbonate. I don't want carbonate, I want bicarbonate. So I'm going to take my structure for carbonate, which is C double bond O, O minus O. And all I'm going to do is I'm going to tack on a little O right there. So if I know carbonate, I automatically know bicarbonate here, because this is going to be HCO3 minus 1 here. Okay, this is going to be minus 1 here. So again, how do you know? It's because I said that carbon was my center atom, 3 oxygens on the side, and then for bicarbonate, this is HCO3 minus compared to carbonate CO3 2 minus. All I did was tack on a small little proton H right over here. Okay, so bicarbonate is baking soda, okay, HCO3 minus. Back in the day, there was this really famous song that said baking soda, I got baking soda. So that's literally bicarbonate and sodium bicarbonate, guys. Okay, so that's a little fun way to memorize carbonate and bicarbonate. Okay, and that's gonna be sodium carbonate and sodium bicarbonate. And then that's gonna be our next one, guys. We're crunching through these. Next one is gonna be the oxyanions, BrO4 minus, BrO4 minus. Ton of these ones, BrO4 minus. So same idea here, chat. So how many valence electrons? So the number of valence electrons is going to be equal to, okay, bromine is going to have 7, and then I have 4 oxygens, which each donate 6 plus 1. So that's BrO4 minus 1. So in total, 4 times 6 is 24. 24 plus 8 is 32. Okay, so 32 is not a multiple. Oh yeah, 32 is a multiple of 8, right? So that's an indicator that I'm not going to break the octet rule here. So that's going to be potential indicator. Now, the only thing is I do have bromine here. I only have 4 of them. Yeah, it's going to take practice. Narcy, good to see you. Thank you for the love. How's it going? So then I have Br in the center. And then I'm going to attach oxygen to the 4 sides here. Okay, now the only remaining question is if I want these 32 electrons and I only want 1 minus charge, how do I explain this? I already know off the bat that I'm going to have multiple double bonds. Okay, multiple double bonds, because I know that a single bond oxygen is going to have 1 charge. Okay, let me build up to that. That was a little bit too fast. Because you're going to say, how do you know? Okay, so I'm going to put bromine in the center. And then I'm going to put oxygen on the side. Okay, so if I have bromine in the center and oxygen on the side, I know my overall valency is going to be -1. So my goal is to have overall -1, right? Overall minus 1. Maybe I'm going too fast. I'm going to try to slow down a bit, guys. Is YouTube down? What do you mean is YouTube down? Okay, so then bromine is going to be, yeah, I'm going live tomorrow. Tomorrow's going to be the live stream where I go over these problems with my Zoom class. So just DM me if you want to join, Andrea. Good question. Okay, so I'm going to start off with single bonds. But I know every time I have oxygen with single bonds, that's going to create a -1 charge, right? So suppose I do this. Suppose I add all the valence electrons. So I have a problem. The reason I don't want to do this is because I'm going to have my formal charge is, okay, if I have a single bond, 1, 2, 3, 4, 5, 6, and calculate my formal charge, what's the equation for a formal charge? It's the number of valence electrons minus the number of dots plus lines. So my number of valence electrons for oxygen is 6. How many dots? 1, 2, 3, 4, 5, 6. Okay. How many lines? 1 line. Okay. 6 minus 6 plus 1 is 6 minus 7. That's -1. Okay. So this is a -1 charge here. I'm not going to repeat that process for these three. I want you to do that by yourself. But if I do that for all three of these, I'm going to have -1 here, -1 here, -1 here. So if the solution was BrO4 minus, if this was a real thing, then I would be solid. So this is BrO4 minus. Why is it 4 minus? Because I have 1, 2, 3, 4 minus charge. But I don't have BrO4 minus. I have BrO4 minus. Confusing, I know. So what I want to do, chat, is I want to donate some of these lone pairs. I want to donate and then get rid of that minus charge and turn it into a double bond. Okay, I'm going to get rid of this minus charge and turn it into, guess what, a double bond, right? And then I'm going to do that one more time. Get rid of this minus charge, turn that into a double bond. So now I have BrO4 1 minus here. Okay, so now I know I'm done because I have BrO4 with only a minus charge here. The only crazy thing is that we broke the octet rule again. So we have 2, 4, 6, 8, 10, 12, 14 electrons on bromine, which is very, very rare. We do not often break the octet rule. Wait, YouTube is crashed? Wait, YouTube crashed? I'm on YouTube. Wait, YouTube crashed? Wait, that's crazy. Okay, so that's BrO4 minus. Yes, daily dose. This is an exception. You typically need 8, but bromine has an exception here because we need to satisfy the charge balance. Okay. Exception. Bromine has way more than 8 valence electrons. Okay. So sometimes there's going to be exceptions. These are college level. These are going to be college level Lewis structures. Daily Dose says, oh, you can do that? Yes, you can do that, okay? Sometimes you have to break the octet rule in order to satisfy the charge balance, okay? Great question. Great question. You might say, hey, why do they call it the octet rule? I don't know. Why do they call it the octet rule if you're going to keep breaking that rule, right? Crazy, right? Okay, so this is our next one, chat. Let's see how we're doing. Let's see how we're doing. We have all these different structures. And again, if I'm going too fast, I'm going to post this on my YouTube channel later today so you can rewatch the whole thing. Okay, next one is SeO42 minus. SeO42 minus. Okay, so next one is going to be SeO42 minus. So same idea here. Same idea. First things first, I'm going to do the valence electrons. First things first, I'm going to do the valence electrons here. So if I have Se, now I don't know where Se lives, so I'm going to check the periodic table. So Se lives right under sulfur, which lives right under oxygen. So I'm going to assume that Se has 6. Okay, so Se has a total of 6 valence electrons, plus oxygen has also 6 plus another 2. So this is SeO4 2 minus. Okay, so that's SeO4 2 minus. Let me get rid of that. I'm going to assume that my center atom is Se. And then I'm going to put oxygen on the side just like that. Okay, I'm going to have oxygen just like that. O4 2 minus. So I want my overall charge to be what? What's my overall charge going to be here, chat, for SeO4 2 minus? What's my overall charge? Okay, what's going to be my overall charge here for SeO4 2 minus? So the overall charge is going to be 2 minus. Good job, right? So good job, Narcy. So there's going to be 2 minus. Good job, it's G. So my overall charge is going to be minus 2 here. So I want to satisfy the octet. I'm going to do the same process as last time. I'm going to add all my valence electrons here. So similarly, I have another problem. Because if I do my dots plus lines here, formal charge, single bond oxygen gonna have a valence, a formal charge of -1. So at the moment, I have 1, 2, 3, 4, -4. I don't want -4, so I gotta get rid of some of these single bonds and turn it into a double bond. I'm gonna get rid of that one and that one here. So now I have a double bond and a double bond. So now this is SeO4 2 minus here. I think we are solid here, chat. I think we are solid. Now, interestingly enough, we are going to have some isomers, which I think you're not going to be required to know, but I could also do SeO, double bond here, and single bond here, single bond here. So we're going to have some isomers on the side here and here. Okay. But I'm not going to worry about that right now. I'm going to just say that this is acceptable. If you're in an organic chemistry class, then yeah, we have to worry about isomers. But this is a Gen Chem review right now. So we're going to focus on this context. It's going to be a single bond, double bond, just like that. All right, guys. So we're making good progress here. Let's check the next example. The next one is going to be HPO4 2 minus, oxyanion HPO4 2 minus. Okay, HPO4 2 minus. Okay, HPO4 2 minus. So first things first, I'm going to check how many valence electrons I have. So I believe phosphorus has 6, right? I'm going to check my periodic table and I see that phosphorus actually has 5. So I have 1. Hydrogen has 1 plus phosphorus has 5 here. Okay, phosphorus has 5 here. Plus 4 times oxygen has 6 plus a 2. Okay, so that's going to be my HPO4 2 minus. Okay, so 1 plus 5 is 6. 6 plus 4 times 6, that's 6 times 5 is 30, plus 2 is 32. Okay, so I have 32 valence electrons. All right, so if I have 32 valence electrons, what am I going to do as the center atom? So I'm going to guess that phosphorus lives in the center, and I have oxygen on the side, just like that. Okay, so I have a couple options here. I could either put my H on my P, which is technically not unlikely, but I have a feeling that it's going to be on my OH here, just like that. Okay? And then similarly, if I know that my single bond oxygens typically have a minus charge, then I know this double bond is going to reduce that charge. So it's going to be something like that. PO4H, PO4 2 minus. HPO4 2 minus. So this is one of my derivatives of the phosphate ion, PO4 3 minus, but this one is HPO4 2 minus. So if I know how to draw phosphate PO4 3 minus, then I know how to draw HPO4 2 minus. I just put up one of my OHs on my oxygen here. Okay, so this one is HPO4 2 minus here. Okay, that's one of my derivatives of phosphate. Phosphate is going to be found in the cell. We have phosphate in the cell, in the phospholipid bilayer. Okay, and great, guys. So guys, do me a favor and drop a thumbs up if you're still with me. Okay, so far so good. Drop a thumbs up if you're still following along and this is making sense, or drop a crying emoji if you're lost and a little bit confused. Don't be shy. Okay, if this is making sense still and you're following along, let me see some thumbs up emojis. And if you got lost at any point, let's see that crying emoji. I want to do a quick check-in to see how we're doing with these practice problems. Okay, I'm gonna go ahead and go on to the next example here. Phosphorus and DNA, exactly, right? So I think we did some of these ones. Okay, we're gonna do this one next. So this one's like a word problem. Okay, this one says chlorine combines with oxygen in several proportions. Dichlorine monoxide, Cl2O, is used in manufacturing bleaching agents. Potassium chlorate, KClO3, is used in oxygen generators aboard aircraft. Draw the Lewis structures for Cl2O and ClO3 minus. Cl is the central atom. All right, we're going to repeat that process and draw the Lewis structures. We have Cl2O. We have Cl2O. Okay, so that's going to be my first one, Cl2O, and that's going to be my center atom. So the reason this one's a little tricky is because we have chlorine bonded to Cl2O, dichlorine monoxide. Well, this is kind of like H2. This is reminding me a little bit of like H2O or F. We have F2O. I'm not sure. So I'm gonna just guess that oxygen. It says Cl is the central atom. That's throwing me off. So if Cl is the central atom, okay, that's throwing me off, chat. I don't think that's. Is that right? So I have Cl 1, 2, 3, 4, 5. No, that's not right. This is plus 2. This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So this isn't right because we have plus 2. I don't know why it says Cl is the central atom. That's throwing me off, chat. So here's what we're going to do. We're going to make that oxygen as the center atom. We're going to make oxygen as the center atom. I'm going to bond my Cl's to the side, just like that. There we go. And that should be right here, right? So I have my 2 lone pairs for oxygen. It looks quite like water. This looks quite like H2O. That's very interesting. So if I have water, H2O, okay, versus Cl2O, that's very similar Lewis structure. Now for ClO3, now this one I'd like to make my center atom. ClO3, yes, now this one I'd like to make my center atom. That is Cl. Let's try bonding it to 3 different oxygens. What if I try two double bonds and 1 single bond? Okay? What if I try 2 double bonds and 1 single bond? So then I have my 2, 4, 6, 8, 10, 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So how many valence electrons do we have here? I have 7 plus 6 times 3 plus 1. So I have 8 plus 18 is going to be 26. 26 valence electrons. 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Why am I missing 2? I gotta put some right there on the chlorine. 1, 2, 3, 4, 5, 6, 7. Yeah. So chlorine has a lone pair just like that. So this is another exception, chat. So how do I explain this better? How do I make this really, really easy to see? How do I make this really, really easy to see? So I know that chlorine likes to have 7, right? Because I have 7 valence electrons minus how many dots plus lines? 1, 2, 2 dots. How many lines? 1, 2, 3, 4, 5 lines. So 7 minus 7 equals 0. Okay, so overall I have a -1 charge. Okay, so overall I have a -1 charge, just like that. Okay, that's going to be my next one here. So that was number 83. Let's proceed here with another problem, just crunching out through these. Next one's going to be 4. Okay, I'm going to skip that one. It's not a Lewis structure. Okay, now we have a bunch of these ones. Okay, now we have a bunch of these. Okay, now we have a bunch of these here. So I'm going to start off with number 23. So we're going to do a different chapter now. So we're going to do a different chapter, namely in this textbook that I'm going through. We're going to do kind of the same idea, though. It's relatively the same topic. It's still going to be Lewis structures, but now we're going to add an extra layer. We're going to talk about molecular geometry. Okay, so we have to determine the molecular geometry for each of the following ions, starting with NH4+. So I'm going to do the molecular geometry for each of the following ions, starting with NH4+. I'm going to take a small sip of water. Guys, let me know who's still with me. Let me know who's still with me. Comment a thumbs up emoji if you're still alive here. Comment a thumbs up emoji if you're still alive. I'm going to take a quick intermission, reintroduce my account. Yo, it's G still here, low key. Okay, low key, so are you in the Discord? Are you in the Discord, my friend? It's a free community that you can join by typing that link in bio. Okay, and then click on engineerminds.co and then click on the Discord. You might love it because there's cool people there and lots of STEM majors, and it's very interactive and inspiring to see other students. So you might want to join in if you want. It's 100% free. Okay, anyone else still with me here? Comment a thumbs up emoji or comment down below if you're still alive in the live stream. Okay. That being said, I think I'm going to go ahead and continue. Just wanted to take a quick little water break, quick little advertising break, and then I'm going to continue on. And then again, guys, if you're taking Gen Chem right now, you can sign up for the free review session tomorrow at 6 o'clock PST by typing that link in bio. Bro, Discord, like, to me, it's confusing, but it's like a giant group chat. You know what I mean? So, like, yeah, it's confusing at first, but then once you get the hang of it, it's pretty fun. Okay. So we have to determine the molecular geometries of the following ions. And then I'm going to start off with the first one is NH4+. Okay. So NH4+. First things first. Before I even consider the molecular geometry, I need to draw the Lewis structure. So that's why you got to be really good at Lewis structures, because I got to draw out N. And then I need to know that ammonium is going to be NH4+. Okay. So I kind of just drew it right away. Hey, mathematic fanatic. So ammonium is going to look like this, chat. So that's because I know that my steric number here is 4. Okay. And I have a complete octet rule here. I have a complete octet. Hello. Just doing some chem practice problems. How's it going? And then if my octet is complete, yep, there's a review for chem tomorrow. You see that sign up above? Free Gen Chem review session. So if my octet is complete, then I'm going to have NH4+ here, right? And so the shape of this is called... Notice the shape that I'm generating here, chat. I'm going to do my best to draw this carefully. I see this shape is like this pyramid shape. And I see that my atoms in between are creating this kind of pyramidal shape just like that. So the name of this shape is called tetrahedral. Okay? So the molecular geometry for this particular compound here is called tetrahedral. Okay? So that's going to be our first shape here. It's going to be called tetrahedral. So tetrahedral just means we have this kind of pyramidal kind of shape, right? All right. And then the next things we're going to do the molecular geometry for CO3 2-. So wait a second, didn't we already do that one? So if you recall from earlier, we did carbonate and we did bicarbonate. So does anyone remember the Lewis structure for CO3 2-? No, it's gonna be this stuff. Basically everything I'm going over right now, low key. It's gonna be everything I'm going over right now plus a little bit more. Okay, So it's going to be mostly like Gen Chem 1. Gen Chem 1. So if you recall the Lewis structure for CO32-, remember I put C here in the middle and then oxygen here on the sides. And then I'm going to put a bracket here to indicate that 2- charges from here and here. Okay? So that's going to be my CO3 2- here. And so what's the shape of this? What's the shape of this? Well, every time I have a double bond, that's telling me I have a planar 2D shape here. And notice that I have a kind of triangle shape here. Notice that I have a kind of, okay, if I were to draw a line connecting each of these atoms, it would look something like that. So to me, that looks like a triangle. And so the name of the shape is going to be called trigonal planar. Trigonal planar. It's a flat triangle. Okay, I'm going to erase this one and then I'm going to put that right over here. That's going to be called trigonal planar. Okay? All right, so that's going to be my CO3 2-. The next one I'm going to do is NO2-. NO2-. This is nitrite. Okay, NO2-. So now I got to do the Lewis structure for NO2-. So I'm going to put an N, I'm going to put an O, and then I know I'm going to have a double bond O and then a single bond. So you might say, how do you know? Well, because I practice here. So, okay, so what did I do here? So I kind of just gave this one away. So I have nitrogen here is in the center. So mostly Chem 1, I need for help for thermodynamics. If you send me some problems as G, or if you drop them in the Discord, I can help you out, bro. For thermo? Yeah, because thermo can be tough. I'm not going to lie. I'm not going to front. So this is my nitrite ion. So this is my nitrite ion. This is going to be a -1 charge. So my nitrite ion, I have N, double bond O, single bond O minus. Okay, so this is my nitrite ion. And then, so I notice I have this kind of bent structure. So it's kind of like a line. It looks like a boomerang. The reason it looks like a boomerang is because this electron pair is pushing it down. This electron pair is pushing this one down. This one is rigid. It can't be pushed down, so this one is pushing this one down. Okay? So the name of this is going to be called bent. The name of this is called bent. Okay? What's the name of that? It's called bent because it's kind of pushing it down. Okay? All right, the next one I'm going to do is XeF5 plus. So it's going to be another exception. Banan, how's it going? Welcome in. So I'm going to do XeF5 plus, XeF5 plus. So if I have Xe, that's telling me I'm bonded to 5 different F atoms, just like that. Okay, so if I have XeF5 plus, so I need to make sure that my octet is going to be either complete or broken. So if I have 1, 2, 3, 4, 5, I need 2 more valence electrons to have that formal charge of 0. I got to make a video complaining about octet rule because it's just not a good rule. It's broken so many times that it's just not a good rule, that I need to prioritize my charges. Okay, that's a good question. Wait, that's a really good point. Octet rule is broken, but also it's noble. So how can we have a noble gas? Wait, that's a really good question. How can we have a noble gas as a compound if it's a noble gas? That's a really good question. Okay, I gotta look into that. That's a really good question. Okay, that aside, putting that aside, I'll look into that. Putting that aside, we're still gonna have Xe break the octet rule with 2, 4, 6, 8, 10 valence electrons. I know like 4 things about chemistry, and that's one of the that's one of the most important things to know is about noble gases in the octet rule. So the name of this shape, okay, this shape is kind of hard to visualize at first, so I'm gonna put it like this. I'm gonna put Xe, and then I'm gonna put my fluorine. I'm gonna put my lone pair up on top. If I put my lone pair up on top, no, I'm gonna put my lone pair. Where should I put my lone pair? I'm gonna put it up on the bottom. If I put my fluorine over here, 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 and then here, aha! Now I see what shape I have. This is going up, side, side, side. So this is kind of like a square pyramid. So the name of this shape here in the molecular geometry is called square pyramidal. Pyramidal. Square pyramidal. Okay. Yeah, it's not a platonic solid. Yeah, it's not a platonic solid. The other ones are platonic solids though. Okay. If we include the electronic geometry, by the way, if we include the electronic geometry, where now we consider the valence electrons, is going to be an octahedral, then it is going to be a, let's suppose that this electronic geometry means that we consider the electrons. So we still have a square base, but then I'm going to connect now to the electron pair down here. So my drawing is not the best here, but I kind of have like a double pyramid. So this one I think is a platonic solid. I think this one is a platonic solid. This is going to be octahedral. This is going to be called octahedral. Math fan, let me know if that's a platonic solid. Is octahedral a platonic solid? Not to be confused with tetrahedral. Which looks like that. That's going to be tetrahedral. Oh, interesting. Wait, your profile is a octahedron? That's crazy. Oh, wow. I just noticed that. That's awesome. From my perspective, it just looks like a hex. I never noticed that. I never looked at your profile until now, dude. That's sick. From my perspective, it looks like a hexagon with a triangle. But now I see it as an octahedral. That's sick. That's sick. That's sick. That's sick. Okay, guys. I'm not gonna lie, I'm getting a little bit fatigued. Not fatigued, it's just my voice. Like, I feel my voice is kind of dying already. So I think I'm gonna end it. That was a good run. We did about like, how many did we do? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We did about like 17 or 18 Lewis structures. So yeah, I'm pretty much gonna end it here. And yeah, I'm just gonna upload this up on my YouTube channel so folks can check that out. And yeah, guys, peace out. My name is Dr. Drew. Sign up for tutoring at the link in bio. You can sign up for the Discord. And guys, anyone that needs any help with math, gen chem, ochem, physics, feel free to shoot me a DM, shoot me a follow. You can catch me on IG and live on TikTok Monday through Wednesday. This was a prep for my midterm review that I'm going to lead tomorrow, Wednesday at 6 o'clock. And it's going to be live on Zoom. So DM me for the link if you want to join. Yeah, guys. It looks a bit 2D TBH, but it's intended to be an octahedron. Nice. Nice, nice, nice. I love it. Very creative. All right, guys. Pretty much going to end it. I will see y'all tomorrow. Peace and love. Peace out.